Hello, good morning, everyone. Thank you for joining in this fourth session of the Matlab short course. Um, I just want to make sure that you guys can see the screen. Can someone, just confirm they see Matlab screen? Anyone? No one can see. Oh, okay. I see in the chat. Yeah, perfect. Thank you so much. Okay, so today we want to cover something extremely important. It's in a sense recap of all what we have done so far. So far, we learned something about plotting. We learned something about basic arrays operations. We learned the key elements of programming. So if statements, loops, whether while or for loops. But as a recap on all of this, we are going to learn today the so-called MATLAB user-defined functions. And let me maybe share a whiteboard for a second just to illustrate the idea. So I'm sharing a whiteboard now. So the idea is the concept, the so-called modular programming. And the idea of modular programming is sometimes you work in a team, in a project, or even if one of you alone is working on a project, and that project requires coding a lot of pieces. So, for example, let's say this is a big engineering project. Part of it requires, plotting. Part of it requires some sort of integration calculations. Some sort of requires differential equation solutions. Maybe linear systems of equations. There could be diverse things that you can do in a big project, and then you would like to divide this project into pieces. As we learn it, whenever you have a big problem, it's better if you cut it in small pieces. So you might want to say, haha, so the first chunk of this project is going to be on integration. The second chunk of this project is going to be related to, plotting functions and results and stuff like that. Third part is doing blah, blah, blah. Fourth part is different story, and so on. So you can code every one separately. You don't need to work on all of them at the same time. So you can code every one separately. And then there could be some sort of, a main program or a main code, which could be a simple MATLAB script. It could be a very, very tiny script. That script could be the one that reads information from user, and then it communicates and coordinates with all these small programs so whenever it needs an integration, it goes ask the integration part to do it. Whenever it needs plotting, it goes to the plotting part to do it, and so on and so forth. So it's kind of coordinating between them. Each one of the small codes in MATLAB, we usually call it a function, a user-defined function. So each one of these little codes is going to be called a function. And today, the scope of this session is to show you how to write MATLAB functions. That's the whole idea, okay? And again, if you have a big project, you can divide it into small functions, and then a big script or a main script can coordinate and call these functions. So it sends information to this function, ask it to do a job, and then gets back the result, send it to another function, it do another job, and take back the result, and so on and so forth. Okay, very extremely important concept. Modern projects in engineering are all based on this concept of modular programming. Okay, so what is the first thing, as always, is what is the syntax of a MATLAB function? Okay, so let me actually do this here, or actually let's do it on an actual M file. I can close this. I can stop sharing this, and I can open a new one, which is basically the MATLAB. Okay, I'm gonna, so maybe let me just go to the desktop here. Okay, so that's not a big deal now. So let's open a new script. So this is a standard script. So far, nothing new. This is the normal script that we have seen so far. But if you want to turn this into a function, you need to start by typing the word function. And automatically, Matlab writes it in blue because it recognizes that this is something related to its syntax. Typically, you list a set of outputs that you are requiring from this function between square brackets. So maybe out1, out2, out3, and so on and so forth. Of course, the names could be anything. They don't have to be called out1 and out2 and out3. You know, they could be anything. Okay, X, Y, Z, for example. These are the outputs. Then that equals the name of the function itself. Let's call it, for example, my first function. Then between two brackets, you're gonna put the input, stuff that the function needs in order to calculate or to do its job. So for example, this could be input number 1, input number 2, input number 3, and so on and so forth. Then when you save it, when you save this function, so if I type save here, in fact, let me do this in the desktop, MATLAB short course, session 4. So when you save it, and I want this, it's now saved, but I just want to go to the folder where this is located. Actually, let me do this from here. Okay, so this one here. So this is what I wanted to bring you to your attention. Since this was saved as a function, it's actually, if you look at the symbol here, it has this fx. I don't know if you see it well on the screen here. So f sub x. So MATLAB recognizes this now as a function. I wouldn't put anything before the word function. So if this is the first, if this file is going to be for a certain function, don't put anything above the word function. The name of the file has to exactly match the name of the function. So if this is called my underscore first underscore function, it has to be named my underscore first underscore function. You change the name, you change the file name as well. Okay. What else? Don't do clear all, close all, and CLC and stuff like that, because in the function, you don't want to erase the memory. In fact, you want to receive some information from the memory of another code, use it here, and then output the results to the main code. So you don't need to clear all or to do anything like that. And in fact, but that's a little bit advanced, and maybe we don't need to delve deeper into this. So the memory of the MATLAB function is independent of the memory of the command window. In other words, you could have a variable called x, and x equals 7 inside the function, but x equals 2000 outside the function, maybe in the command window, and that's totally fine. Like here, your x could be 21, and here inside the function could start with x equals 7, and that's totally fine. So MATLAB is not unhappy here, because the memory of the function in the computer is independent from there. However, they can communicate. You can pass variable from here to there, and so on and so forth. Okay. All right. So that's basically the layout of the. But what do you do inside the function? Well, you just code. You can ask for plotting. You can do if statements. You can do while loops. You can do whatever you want. Okay. So that's as simple as this. So let's test using functions. And again, let me emphasize this. These kind of functions that we do this way are called user-defined functions, because there's something called MATLAB built-in functions. Built-in means you buy MATLAB, they come with the license automatically. Like, for example, MATLAB has a function called max that calculates the maximum element in an array, mean to calculate the average, F0 to find the root of nonlinear equation. There is the slash thing, which solves a system of linear equations. So these are all built-in utilities or functions inside MATLAB, while what we are doing is something on top of what MATLAB already has. prepared for us. So that's why it's called a user-defined function. If there are no questions, I can actually move on and start doing the first exercise, which is you can. Oh, okay. Well, let me copy in the window here where it is located. It's in our MATLAB shared folder drive. So it's this one. Let me get a link. Copy. I'm just gonna copy this in the chat. Where is the chat here? Yeah, here we go. So I can paste it here. So guys, our exercises as always is in the shared folder, so you can just go there and get it. Meanwhile, let me share a screen one more time, and that's our exercise. So we want to do this one. It's a very simple exercise, but it's gonna illustrate a lot of the concepts that we mentioned. We are asking you to write a MATLAB built-in function that reads an array of numbers, okay, and calculates the maximum number and the average. So it's gonna calculate the max and calculate the average. We are asking you to validate your function against MATLAB built-in function. So MATLAB has already a function called mean, okay? So mean is a built-in function, and it has another one that's called max, which the first can calculate the average and the second calculate the max. But we want to validate our own built-in, our own written function with the one that MATLAB provides. So let me go back here. I'm going to modify this. First of all, I'm going to call it my max average. Let's say this way. So it's going to calculate the maximum and the average. It does not read 3 inputs. It just wants 1 input, which is an array of elements. So, for example, that array can be called X. Okay. And how many outputs it's going to give to the user? Well, it can give them, 2 outputs. So my max, and you might notice I'm kind of insisting on calling it my max rather than max. Does anyone know why this is the case? Why I'm keep insisting that? Probably we've discussed this at the previous point. Type in the chat if you know, or just unmute yourself. So it's basically to not coincide or cause an overlap with the built-in stuff inside MATLAB. So the built-in stuff inside MATLAB is called max, and you don't want to create this overlap. So that's why I keep trying to use something that's not inside MATLAB. So I'm calling it my max. The other one is going to be my average, although the one in MATLAB is called mean, but just to distinguish it. So if you go, just a second, guys, give me a second, please. All right, we are back. So I'm sharing a whiteboard for a second. Just remember, these are simple ideas. How do you calculate the average or the maximum number of elements? So let's think, it's always before you start coding, it's always good to brainstorm. So I'm gonna brainstorm a little bit here. So suppose I'm given X, a bunch of elements, let's say 4, 7, 20, -1, 2, okay? So obviously, if I want to calculate the average, I know that I need to sum these elements, and we learned how to do summations before. Like I want to calculate 4 plus 7. Although I could even use a built-in function in MATLAB to do the summing for me, but at least let's review the concept of summing. It's quite useful. So I need to sum these numbers, right? And then divide them by the number of elements. Here, you might actually write a piece of code that finds the number of elements in the array X So you could, for example, write a code to tell you that there are 5 elements here. So there is 1 element, 2 elements, 3 elements, 4 elements, and 5 elements. But this is going to be a little bit as an overkill, because you can, here you might actually say, let me use a built-in function already. And Matlab already gives you a nice built-in function called length. So length of X tells you exactly how many elements in the array X. So this one has 5 elements, so it's going to be 5. Length of X is going to be 5. So this is an easy way to calculate the average. So I'm going to stop sharing. I'm going to code this part. I'm going to code this simple part here. So I read X. I can, for example, call n equal length of X. So that's basically, and write a comment here. So getting the number of elements in array X. As always, we learned how to do the summing. We have done a couple of exercises on this. I can define a variable called sum, 0 at the beginning, because gradually I will keep adding elements to this sum variable. So obviously I need a for loop. I'm gonna start the loop from 1. Where should I stop, guys? I need to sum all the elements in the array X. Where should I stop? Can you type in the chat, please, if you know where I should stop? Should I stop at 5 because the array had 5 elements, so I need to sum all the elements? But what if the user next time gives me an array that has 20 elements? So up to the end, yes, but how do I make it general, regardless of the size? N, yes, excellent. So I need to stop at n here, which is length of X. So if the user give me an array that contains 700 elements, then n is going to be 700, and that's the correct stopping for this. And here I'm going to put an n statement. Now I do the sum trick, which we have learned before. So sum equals sum plus what? Plus So what am I summing? I'm summing elements of the array X. So I'm summing X of K. So if you follow this loop, in the first time sum equals 0. And then once we enter inside the loop, sum is going to be the previous value for sum, which is 0, right? Plus X of 1. So that's the first element in the array. So if you go back to the array that we wrote, let me share a screen one more time. So the first element is 4. So X of 1 is 4. Okay, and then X of 2 is 7, X of 3 is 20, and so on and so forth. So if you go back to the MATLAB screen here, so sum equals sum plus X of K. So that's how it keeps adding the terms of the array X one at a time. Okay, and after we finish the looping and we calculate the sum, we can say that my average is the sum, right? The numerator, which is the sum, divided by what? The number of elements, which is n. I can actually put a semicolon here. So that finishes the part of the goal of this function, which is calculating sums, right? In fact, let's go back to the whiteboard. If you see here, if you see here, we actually find a way to calculate the sum. Calculating the max is relying on a little simple idea, which is, in spite of being simple, but it's quite useful in several algorithms that appears in engineering. So with an eye inspection, obviously we know that 20 is the largest element, but of course you don't know a priori this, especially if the array is huge, like contains thousands of elements, so you cannot detect it by the eye. So how do we put something systematic to find the biggest element? So I hope you see my whiteboard now. Look, the idea is simple. You start with claiming that the first element in the array is the biggest guy, is the maximum guy. So I can actually claim down here, just to learn how the idea of the algorithm works, I can claim that my max equals 4. Okay. Then inside the loop itself, remember the loop goes over all the elements. I need to check if when the loop starts, the first time it's gonna go actually to 4. I need to compare, is my max greater, is my max smaller than this element? Well, it's actually exactly the same. So since it's exactly the same, my max remains as is. It's gonna be 4, and we are good. The loop loops one more time. It goes to the next element in the array, which is 7. And then I ask the array, is my max greater or less than 7? If it is less than 7, then I should claim that my max is not 4. Instead, it's actually going to be 7. My max is going to be 7. And then I go loop one more time, ask the array, what is my max less than this value of this element of x, which is 20? Yes, it is less. Then my max is going to be 20. And then I keep looping. I go to -1. Well, no, 20 is greater than -1, so I am okay. I'm gonna keep it, and I will keep doing this over all the elements. This way, in the memory of the computer, my max will keep updating whenever it finds a bigger element. If there are no bigger elements, if there are no larger elements, then I'm good. I have the max now. Okay, so that's basically a simple algorithm. Let me stop sharing here and go back to the coding window. This is a very simple algorithm that allows you finding the maximum element. So let's code this together. Before we enter the loop, I'm going to claim that my max equals x of 1, right, which is the first element of the array x, regardless of the size of it. And inside the for loop, I need to do some check. Well, if my max is less than x of k, which is the current x I am investigating. So the loop is gonna loop over all of them, which is the current x I'm investigating. Then what should I do? Then my max, the new value of my max has to be x of k, right? Then I need to end the if statement. The question is this unclear to any one of you? How is the search for the maximum is conducted? I'm literally going one by one to see if that element in the array is larger than what I am claiming to be my max or not. And if I found a larger one, I'm gonna assign it to my max. That's basically the idea here. If there are any questions on this, just type in the chat or unmute yourself and speak up loud. Seems we are good. So yeah, okay. So we are good. So I'm done. I'm really done. I'm done with the function. I managed to calculate my average down there, and I managed to calculate my max down there. So let's now use the function. Guys, you can use the function from the command window, right? Or you can use it from a script, provided, and that's very important, provided that the script and the function exist in the same folder in your computer. For example, this is a folder in my computer. It's called session 4 in a folder called Matlab short course for 2022. So maybe I can open a script here. I can call it, let's give it a name, test underscore function. So that's basically a test for this function. What am I gonna put inside the script? Well, I want to call the function. So basically, I want to call the function. So I'm gonna copy this top part here. Okay, and I will put it here. But let me write a comment. This script, remember, this is a symbol script. It's not a function. And please pay attention to the symbol here. I hope you can see it. If it's a function, it has f underscore. If it's a symbol script, it has this Matlab logo on top of a piece of paper, while there it's f of x on top of a piece of paper. So this script is going to call a function named my named what? My first function. My first function. It also compares the results of this user defined function with the built-in functions in Matlab. So first we need a test case. So let's try some array. So let's say the one that we wrote in the example there in the whiteboard there. I think it was 4, 7, 20. By the way, I don't need the commas here, so I can put without the commas. So 20 minus 1 and 0. That's x. Why I have this thing? Yeah. And then you simply call the function. How do you call it? That's it. This line here is how you are gonna call your function that's called my underscore function, my underscore first underscore function. So basically, it's gonna pass the array x to the function and then collect the output from the function. Okay. By the way, there is no reason at all that you have to stick to the name x, to the name my max, or to the name my average. Although in the function itself, this is how the input is written, x, my average, and the outputs are my average and my max. But as I said, there is a complete separation in the memory of MATLAB or the memory of the computer between the names of the variable there and here. So for example, I'm totally fine to call this whatever, z. And then I call the function, I'm gonna give it this z. And the outputs, I can call it, you know, my max 1, my, or x1 and x2 or anything. There's no reason to stick to the names there. That's the key idea I'm trying to say here. I could have called this, you know, x1 and that one is x2, or output 1 and output 2. But just, you know, for the sake of clarity, let me keep it this way. And I'm not gonna put a semicolon here because I want it to appear on the screen, right? What else? I also need to test the results of my code, my function, with the MATLAB built-in utility. So how do I use the built-in utility? Well, I'm gonna type mean of z, and that's gonna basically calculate the mean. And I can also do what? So let me define this as MATLAB mean or MATLAB average equals mean of z. And the other one is going to be called MATLAB, you know, MATLAB max. You can give it whatever name you want. It's going to be max z. So guys, these, the last two below are the the MATLAB built-in functions. Let's compare. I'm going to save. I can clear the memory here in CLC. Let's run this. Oh, apparently there is an issue. There is an issue in, oh, can someone detect the error here? I'm calling a function that's called my max average, which is, yes, it is this function, but there I made a mistake. What is the mistake? The name of the function is not matching the name of the file. So MATLAB is unhappy. So because of this, I should copy this and rename this file, and call it my underscore max underscore average. This way it's gonna work. Yeah, so very important, guys. The name of the function has to match the name of the file in which it's saved. Now let's go back again to our script. I'm gonna clear all and CLC here. So let's run this. Let's compare the results. So we have all the results. That's the array Z. My max is 20 and my average is 6. And you can calculate the average on the calculator to convince yourself. But better, we can compare with the MATLAB results. The MATLAB average is 6 and the MATLAB max is 20 as expected. So guys, clearly, our function actually works well as the MATLAB function. Okay. I have to comment here. Honestly, our function might be a little bit slower than the MATLAB built-in function, especially that's based on a for loop. Whenever there is a for loop and MATLAB can replace this for loop by some sort of an array operation, usually the MATLAB built-in function would be faster. But then you might wonder, why do we need user-defined functions if MATLAB built-in functions are faster? Well, sometimes, and not sometimes, many times, MATLAB doesn't have the job that you want already coded. So you need to code it yourself. That's why you need to make your own functions. Okay. Any question, guys, on this exercise? I want to see here in the chat. If you can type in the chat if you wish, or simply unmute yourself and ask a question. I hope this clarifies how a function is written, that's number one, and how it's called. How do you use it? By the way, I can use it from the command window. So I could have literally done this in the command window. But typically in good engineering programs, you drive a function from another script or from another function. So a function can call another function, and so on and so forth. Okay. All right, if there are no questions, then let's take an exercise. And I think we have here about like 10 participants or so. So we can put you in breakout rooms. You work a little bit on the exercise, and then we come back, solve it together here before we take a short break. So the exercise is in the shared drive link that I shared with you on the chat, and let's together do exercise number one here. It's a simple exercise. We are asking you to write a function that accepts cylindrical coordinates from the user. Basically, if you remember this from calculus, you need r, theta, and z. These are cylindrical coordinates of a point. But however, make sure that r is greater than 0, because it's a radius. Theta is an angle somewhere between 0 and 2 pi. So automatically, the user should give you the angle in radians, and somewhere between 0 and 2 pi. Make sure that, well, z could take any value, because that's, a height on the z-axis, so it could be anywhere. Your function should take these 3 inputs from the user, possibly doing these checks, and then it's going to calculate the Cartesian coordinates x, y, z. For those of you who don't recall this, please take a note here. Maybe I can type this here. The purpose is not to do calculus in these sessions, but this is a reminder. X is going to be r cosine theta, and y is going to be r sine theta. And z is just z, nothing different. However, we are asking you also to calculate the distance between this point and the origin. So, and as a reminder, the distance d is the square root of x squared plus y squared plus z squared. Note these downs and down in a piece of paper. Please start coding. Share your screen. I'm gonna pass by in the breakout rooms to see how things are going. So let's stop the share. Let's stop the recording.